Dear students, through this presentation, we will explore the biography of one of the most brilliant mathematicians in history, Srinivasa Ramanujan. His contributions to mathematics have left an indelible mark, inspiring mathematicians worldwide. Let's explore his life, work, and legacy. Srinivasa Ramanujan was born on December 22, 1887, in Erode, Tamil Nadu, India, to Kuppuswamy Srinivasa Iyengar and Komalattamal. Despite humble beginnings, his genius was evident early on. His primary school was Kangayam in Kumbakonam at the age of 7. Ramanujan's brilliance shone as he topped the Tanjore district primary examinations. This achievement earned him a half-fee concession at Town High School, Kumbakonam, where he studied from 1898 to 1903. Ramanujan's journey into mathematics began with the book Synopsis of Elementary Results in Pure and Applied Mathematics by G. S. Carr. This book became his foundation, igniting a passion for self-study and mathematical discovery. His obsession with mathematics began working independently on mathematical concepts, neglecting other subjects. Now, this already is proven by his life. You can see that where he achieved in mathematics. So it's not actually neglecting the subjects, rather he was more focused on one subject, that is mathematics. That was his passion. Now he focused solely on mathematics, creating numerous theorems and results on his own. This happened from 1907 to 1911. To support himself, Ramanujan worked as a clerk at the Madras Port Trust. Despite the challenges, he continued his mathematical explorations, showing unparalleled dedication to his passion. Ramachandra Rao, a prominent mathematician and astronomer, recognized Ramanujan's potential. He provided financial support and encouraged Ramanujan to correspond with Western mathematicians. Now, this in front of you is a letter where the first letter was posted by Ramanujan to G.H. Hardy on 16th January 1913. He said, "Dear Sir, I beg to introduce myself to you as a clerk in the accounts department of the Port Trust office at Madras on a salary of only £20 per annum. I am now about 23 years of age. I have had no university education, but I have undergone the ordinary school course. After leaving school, I have been employing the spare time at my disposal to work at mathematics. I have not trodden through the conventional regular course which is followed in a university course, but I am striking out a new path for myself. I have made a special investigation of divergent series in general, and the results I get are termed by the local mathematicians as Stirling. Just as in elementary mathematics, you give a meaning to a when a to the power n when n is negative and fractional to conform to the law which holds when n is a positive integer. Similarly, the whole of my investigations proceed on giving a meaning to Eulerian's second integral for all values of n. So the letter goes on about the detailed working of Ramanujan, and he wrote this letter to G.H. Hardy to inspire him, to support him in his future further investigations and work in mathematics. Now, this letter was written by G.H. Hardy to Ramanujan, and he wrote, "I was exceedingly interested by your letter and by the theorems which you state. You will, however, understand that before I can judge properly the value of what you have done, it is essential that I should see proofs of some of your assertions. So you can see that it was not an easy task for Ramanujan to convince G.H. Hardy. In fact, G.H. Hardy went through the work of Ramanujan, and he definitely found some extraordinary outcomes in his work. And he so G.H. Hardy, in fact, went through his work, uh, and he then wrote to Ramanujan, and he called him to London. In 1914, Ramanujan moved to Cambridge Trinity College, and he together with the G.H. Hardy did some groundbreaking work in number theory, infinite series, and continued fractions. Some highlights include the partition function, Mach theta function, and the famous Hardy-Ramanujan number, that is 1729. The story about 1729 goes like this: that once G.H. Hardy visited Ramanujan in the hospital in a taxi with the number 1729. Hardy described the number as dull, but Ramanujan replied that it was a very interesting number, as he said that it was the smallest number that could be expressed as the sum of two cubes in two different ways. 10 and 9, as the cube of 10 is 1000 and the cube of 9 is 729, the sum of the two is 1729. Similar way, the cube of 12 is 1728 and the cube of 1 is 1, so the sum is 1729. So this number 1729 is actually now known as Hardy-Ramanujan number. Now, despite the recognition Ramanujan received, including becoming the first Indian Fellow of the Royal Society, Ramanujan's health suffered due to malnutrition and the harsh English climate. He returned to India in 1919 but continued to struggle with health issues. In his final year, Ramanujan remained committed to mathematics, producing remarkable work despite his declining health. He passed away on April 26, 1920 at just 32 years old in Kumbakonam. Ramanujan left behind notebooks filled with unpublished results which have been extensively studied by mathematicians. His work continues to influence areas like number theory, cryptography, and quantum physics. Ramanujan's contributions, such as the Ramanujan prime and theta function, remain central to mathematics. His birthday, December 22, is celebrated as National Mathematics Day in India, honoring his legacy. Ramanujan's innovative approach to mathematics has had lasting impacts on fields like modular forms and analytic number theory. His intuitive method set him apart as one of history's greatest mathematical minds. So, dear students, here we conclude the presentation on Ramanujan, and mathematics department of your school is going to celebrate today remembering Ramanujan, and a very important topic in mathematics will be explored, that is algebra. Dear students, we believe that algebra is the thread that weaves through all disciplines, transforming abstract ideas into practical solutions.